This is House Planning Help, episode 370. Hello, I'm Ben Adam Smith, and this is the podcast for you if you're interested in self-build or retrofit. I'm exploring what houses we should be building in the 21st century and try to break down the major roadblocks that may get in our way. Coming up in this session, my guest is Florence Collier, founder of Humblebee. We're going to be looking at how you might spend your money on a retrofit and in what order that money is going to be leaving your bank account. And the reason that we set the podcast up this way today is because of Florence's excellent blog. So it's all about her own project, her retrofit, and it details each stage as you go through, and it has some numbers. And we like numbers. We know, obviously they're bespoke to each project, fair enough, and they'll probably go out of date. But it's just a great example, and a massive thank you to Florence for letting us share the numbers here. So if you want to have a look at her blog as we go through the podcast, houseplanninghelp.com/370 today, and that will give you the links that you need to head across. I was chatting to a couple this week who used to live in a passive house, but now live in a retrofit. I think they needed to move, perhaps downsizing a bit, relocating. So they tackled a retrofit of a 1970s property. And I think it was a complete eye-opener. So I was going to say that retrofit is one of those things that's worth knowing about. I think it's almost the more popular thing, or the thing that more of us should be doing, because we all tend to have existing properties that we need to deal with, even if our dream is to build new. And perhaps you've gone down that road, maybe looking for land, and start to realise, hold on, there's not as much land around, or this land is very expensive. And as we get into Florence's story, it was a similar scenario, that this wasn't the first thing on the table. So let's get to our featured interview with mechanical engineer, passive house designer and retrofit assessor Florence Collier. The focus of this episode is on her retrofit in South Manchester, but it wasn't actually the starting point.
We were talking about co-housing. And so for a few years, we'd been looking for sites. So the idea was to build new, but build to a very high standard. We'd already started volunteering for a local climate action group called Transition Town. So carbon was very much at the forefront of what we wanted to reduce in our lives. But along with that was sort of more community-based connection and food growing and just living a bit more of a wholesome life, really, and a pleasant environment for children to grow up in. And that was the utopia.
Trouble with co-housing is it's just so much thought, effort, work when you're teaming with others as well. The kids might have grown up by the time that you got there. You really need to have it ready and in place.
That's right.
Start at 15 and then your kids will be perfectly placed later in life.
Absolutely. Preconception is big.
Exactly. So co-housing, for whatever reason you finally decided wasn't going to work, what's the next option then?
So we were renting at the time, and we were looking for somewhere to buy eventually, but houses in our area just kept going up and up and up. There was never a down period. So it was a case of, well, we took our time, but we just kept an eye on what was available. As I was doing the passive house course, in fact, this property came up, and as a footprint, it was just really simple. It was literally a box, and all these dumb engineers' sketches that we drew as a house kind of seemed to fit this layout that we had. And for the location, the price was actually, it was towards the upper end of our budget, but for the location, it was absolutely spot on. So walking distance from the schools that the children were already at, the high school, the centre of town, parks, the station. So we just decided to jump on it. And as I was doing the passive house course, we were learning about Enofit, and I thought, maybe that's an option.
Well, firstly, I don't think you should be ashamed by a box. Are we calling this a box?
Yeah. Yes,
so no shame here. We like boxes on this podcast, which is good. And it's going to finish up as something better. I think you need to describe the house, and particularly the porch, which I enjoyed.
Oh, yeah. So the house is a typical 70s cavity wall brick construction with ventilated suspended timber floor, or was. It had this horrible plastic portico stuck on at the front where the steps are. So you had to have, there were several steps up to the front door because it's significantly raised. And at the back, we had this porch, which was a brick porch, but with single glazed all around. And it was right in the middle of the elevation. It would just get condensation, mold, which I had to constantly be wiping off. And not only that, but it's sort of from the kitchen window, it just cut off the view of the garden. So in order to do a proper retrofit, it actually made sense to get rid. And so we did.
Well, let's talk about the plans then for this, because you've done some brilliant costings on this. It's very rare that I get to see stuff like this, but you've also done it in time. So as the money is going out, and I just thought that's brilliant for us to see how might the money disappear from our bank accounts. So we're going to do that. But I did have a question about, so what is not included here, because no doubt you've got a lot of professional services that you're probably going to be spending time sorting out the retrofit plan. So what is not included?
So not included is architect's fees, although I might have included just the few details that I asked my architect to do for me. My professional time, so I basically modelled the whole building, came up with all the material decisions and specs, and not that I produced a spec as such, but whenever I commissioned the next piece of work, I kind of laid it all out and we talked about what materials we'd use, etc. I would advise anyone who isn't in the industry or a designer themselves to make sure you do get an architect, just because it is a bit of a minefield. And what else? Just some of the little things. So the decoration, which can all add up, of course. The labour for the loft insulation, that was us. So yes, there are certain things that aren't included in those costs, which could easily add another 10 or 15%, I suspect.
Yeah. So we're just having this as an example. It's perhaps a fair amount of the physical changes, things like your windows, your insulation, air tightness stuff. So we're talking through all of that. But as you look at your 1970s house, your brick house, cavity wall, what is going to be the strategy for it?
Yeah, the plan was to achieve as close as possible to the Enefit standard, which is the Passive House standard for retrofit. And that essentially targets a space heating demand of 25 kilowatt hours per square meter per year. Ultimately, we wanted to reduce our carbon in embodied carbon terms, and well, you can't really reduce your embodied carbon, just keep that as low as possible, but definitely in terms of operational carbon. So eventually moving off fossil fuels was always the goal of the energy piece. And alongside that was the health aspect. So not having to deal with mold and condensation and having fresh air, fresh filtered air.
So what's going to be the first step then?
The first step is to get over any mental blocks that you're having to starting this journey, because it's so easy to say, well, I can't do this unless I've done this. And then there's that. And while we're doing this, why don't we do this? And then you kind of end up in these awful spiraling conversations that never amount to anything. So being in lockdown, having done all the modeling, we thought, well, we're stuck here. We might as well get started on something. And that something was the loft insulation, because it was something we could just order the materials for, look up a YouTube video and get it done, really.
And you're doing this, and the figure that I've got here for the entire loft is £2,700. So I'm imagining that's pretty much just materials.
Yes. Yeah, that is. Yeah.
Anything else to note on this one?
Just that was less than 3% of the total cost. And yet it's an important first step. So through the roof, we were losing between 8 and 10% of the heat loss. So that's already a significant step for not much money. And it's something that people can do themselves. Also, our material costs were possibly a little bit more than a lot of people would spend because we used wood fiber and hemp, which aren't the cheapest insulation products. But when you look at the total, it's still worth it, and also worth working with because they're such nice materials to work with.
We haven't actually talked about how big the house is. So, what floor area is it? And when we come into the loft, how many square meters are we talking about?
Yeah, the loft is about 55 square meters, and total floor area, we've got 110 square meters in the house. It's a 4-bed, although the fourth bedroom is more like a box room, and 1 bathroom, 1 downstairs cloakroom, 1 kitchen.
So that was off the back of lockdown, just keeping you busy. Any challenges in the loft or anything unexpected?
Yes, I fell through the ceiling.
Okay.
So, big health warning, obviously. I had watched the YouTube video and they did talk about putting a board between joists so that you could kneel without actually leaning on the plasterboard below. And somehow I totally forgot that and was kneeling. Then, well, actually, I was lying flat on the ceiling panels and then kneeled up to get up. And that's how I fell through. Luckily, landed on my daughter's bed and she was in the middle of a dance Zoom class downstairs and I had to say, I'm sorry, my mum was just falling through the roof. So that caused a few giggles.
Wow. Okay, so you've got a bit of fixing work to fix the roof, but it reminds me of the sort of thing that my dad would say when I'd gone up into the loft. And that's exactly why, isn't it? But you never get a case study like you've just told us.
It's definitely not designed to take anyone's weight, those plasterboard ceilings.
Fair
So,
enough.
yeah.
Let's talk about the cavity wall insulation because that's the next significant cost that you've got on here that you're totaling up to around about £2,000. Is that fair
Yes.
for
Yes, that's right.
what you're
Yeah.
doing? So tell us what you went for, how you felt about it, because this was perhaps one of the trickier decisions, but I think we all understand why you got here.
Yeah, sure. So I had already started discussions with the Retrofit Hub, who were my retrofit team for the larger work, about sort of scheduling the bigger phase of works. And there was a bit of a delay, just that we couldn't get started for a bit. And I can't remember what the reason was, but that was it. But they did say, well, one of the things you could do is just get someone in to do the cavity wall insulation because that's all pretty much independent. I was given a few people to get quotes from. It's a very straightforward step from that point of view. In terms of the material choice, I've since found out that you could probably use cellulose in a cavity wall.
Really? Wow. Never heard that before.
Well, well, yes, I still have doubts about that. But an architect friend of mine who's done some moisture research in Scotland reckoned above the DPC level, and possibly this is for new build, as long as you've got a DPC and some way of protecting the brick outside, you might be able to get away with cellulose. Anyway, my reason for not going for a natural material in this instance was the sponge effect and risk of drawing any moisture out from the ground. Even though there is a DPC, I wasn't sure, without doing pretty major works, I wasn't sure just what the integrity of that DPC was, etc. But also our southwest face is quite exposed to weather, and I didn't really want that to be an issue. So any kind of moisture trapped in a cavity the cavity is there to sort of conduct away any sort of moisture that gets trapped or condenses on the inside face. So we did end up with polystyrene beads, grey PS, which have a decent thermal conductivity. The newer products have a bit of an adhesive, so they don't sort of just pour out if you ever make a hole in the brickwork, which is what a lot of people have found with the original EPS beads, the white ones. And it was a relatively cheap step to take. And in fact, we did it prior to a winter heating season, and it did make quite a difference, just that cavity being filled. So, yeah, definitely worth it.
And you're living in the house through this whole thing?
Yes.
Right. So you're going to feel each step of the retrofit as it starts to take shape.
Correct. Yeah.
Well, we must have a conversation then about ventilation when we get to that and whether it was the right time. But next on the list, we've got windows as being significant. So if I just reflect on the cavity wall installation, so that was a couple of grand. Our running total to date, we've so far spent around about £4,000. So this is all easy windows. This is quite a bit bigger. This is definitely a significant outgoing. So around about £22,000. So tell us what's happening with the windows and the building.
The windows were double glazed PVC framed, coming to the end of their life. But I really like the aesthetic of timber. So we definitely wanted to go for timber frame also because, well, they're very much more efficient than metal frame to start with. And they don't necessarily degrade in sunlight like PVC might. But also they're not plastic. So having said that, we did go for an external powder coat finish, which increased the sort of warranty of the windows from 5 to 10 years. So that was quite important, especially with the weather we get in the northwest of England. We did go for green building still, which are now 21 degrees windows, but we went for their slightly cheaper range, which wasn't Passive House certified, but it had all the hallmarks of really good quality triple glazed windows in any case. So that was a more of a value decision. And on the modeling, it looked like we were still achieving what we set out to achieve. So yeah. What we did do was simplify the number of panes and openable parts. A lot of the heat loss through windows is actually through the frame. So you're always trying to find the right balance between fixed and openable, because fixed have much narrower frames. And also you want to allow as much of the winter sun coming through as possible, because triple glazed will reduce the transmission of that solar gain as well. So you're trying to keep that nice and high and frame to window ratio low. So we rationalized the number of panes in each opening and just had one openable pane in that opening, as it were. So, and that helps with air tightness as well.
What about when you've put these windows in? Are you actually sorting out the air tightness at that point, or are you deliberately trying to keep it quite drafty? Because I imagine once you've made those windows airtight, you could have problems with ventilation.
That did cross our minds, but because I knew the risks, I knew I was going to have to sort of manage the ventilation, but also the decision to go for MVHR from the outset. So that's mechanical ventilation with heat recovery. So we did order windows that didn't have trickle vents in, because I do find it a little bit ironic that you'd spend that much on triple glazed and timber framed windows, and then you just pierce it with an opening basically. And I am a retrofit assessor. I go around people's homes. 9 times out of 10, those vents are closed off because people have been so uncomfortable with the draft and they're trying to minimize their heating bills. And yeah.
Just going back to the windows then for a moment, were there any challenges in installing the windows?
Well, the way we did it was a very well-known challenge, which is to look after both air tightness and insulation continuity, so avoiding thermal bridging, and because of the size of them as well. And we knew this from the start. It ended up being a room by room, one day, one room endeavor. Whereas if you get your standard double glazing replaced, they will pop one out, pop one in, and they can do a whole elevation in a day. But we were looking after that kind of attention to detail, which basically meant taking your time over it. And also they had to build a plywood box So for each window, they were building a box, fitting the window to the plywood, and then lifting all that into place. And the reason we were doing that was so that you could bring the plane of the window in line with the main insulation layer in the wall construction, which from the outset was going to be external wall installation. So essentially pushing out the window into that layer. And the plywood box was our vehicle to do that, which also had to be taped and sealed for airtightness.
Well, you've mentioned external wall insulation, so let's start moving on there. I did want to say that in your cost breakdown, so let's recap what we mentioned. Windows around about £22,000, but of that installation, 6,000, just to give you a rough idea. So total so far about £26,000. We are now moving on to external wall insulation, and that too, the system that you're using, which I'm sure you're about to tell us more about, is around about £26,000. So again, another significant cost, but there's labour here, which is around about 12,000. So our running total is 52,000 so far. So do you want to tell us about how you came to choose this?
Yeah, sure. If you ever build a passive house from new, then the idea is that you have ideally very distinct layers, going from the inside out. You have your finish, you might have a service void, airtightness layer, which could be at that point. And then you have your structure. And then you have all or most of your insulation on the outside. And the reason for this is because through structure, you can conduct heat out from inside to out. Wherever there's like a junction or a fixing, structure not being generally made of an insulating material. And so wrapping the house with this sort of blanket is a lot more effective than, say, trying to paste bits of insulation around the inside of the house and then finding you've got junctions and corners that you can't deal with. So it was always going to be external wall insulation in order to minimize the thermal bridging. Wanting to minimize our embodied carbon and also just from a general health perspective, both us and for the workers, we were determined to use natural material. And in this case, we used wood fiber. Not only that, because it is an existing construction, which was designed to be vapor permeable. So we talk about breathable, but what we really mean is the vapor moving through the brickwork in and out. So when there is moisture, it travels in, and when there's hot seasons or hot weather or hot temperatures, that gets evaporated back out into the space or outside. So what wood fiber would allows us to do is to keep that breathability so that we don't then encounter problems within the structure. And in order to maintain that breathability, but also have a weatherproof layer, we then went for a lime render as a finish, mainly. We did want to sort of break up the box look. So we did have an area so that the ground floor frontage has a membrane, an airtightness membrane, and battens and timber cladding for a bit of variety.
What about time, though? How much time has gone past as we put on the external wall insulation?
Yes, because we're also doing quite a bit of groundworks as well. And I think it must have taken 3 months overall, was it? Of maybe 6 to 8 weeks.
Did you talk about digging down there around the perimeter foundations or whatever that bit's called?
So this is another sort of thermal bridge issue, and also to make the floor more performing. So we wanted to continue the insulation layer down as far as the floor, well, as far as the actual walls were going, because the subfloor is also an influence in the in your heat losses. And so it was wood fiber from the DPC upwards, but below that we had a skirt, and then they installed an XPS so polystyrene plinth. And that's so that you can wrap all the way around, but also put in a sort of French drain type system, gravel, to sort of channel any water, standing water away from the building itself. So there was a bit of digging and they managed to hit a water pipe. I was on a Zoom call to see this big fountain outside my window.
They're very pressurized, aren't they? So if you don't know much about it, you don't realize it because it's all cranked down, isn't it, when it enters the
Yeah.
house? But yeah. So you've got
Yeah.
this flood of water. How did they stop it?
First with their own sort of hands and bodies, I think. And then by a stroke of luck, there was somebody doing some groundworks just down the road and they had a van full of fittings. And so we were able to pay for the fitting and he fitted the connection between new and old pipes. So that luckily got sorted, which brings us on to another issue, which is know where your services are as much as possible. There are actually websites. So there's one called Before You Dig or something like that. And you can put in your postcode and they will get all the utilities companies to send you like a map of that area if there is information.
I can't remember whether it was the water or electricity for our house. And they had to come about 3 times because they didn't know where all their bits were.
Yes, it's theoretical.
It's theoretical and it will get better. But
yes. And a lot of those services, they just stop in the street. So you don't actually know where they come in. But because of the garage, which is where the gas meter was, and a lot of the cabling, there was that information. It's just the water just stopped in the manhole in the street.
we're coming on to your home territory now, MVHR. So I imagine this is the fun bit for you. But I've got a curveball question here. Did you design this first? Okay, as they always say, oh, yeah, you should start with a ventilation system.
I think I did everything in parallel pretty much. And I did make sure that I could see a route for ductwork before I embarked on the idea that we would, tighten up and go for no trickle vents and all that stuff.
So the form is helping here, isn't it? Because it's nice and simple. But where are you going to hide these ducts? And where's the machine going?
It was pretty clear we didn't really have the space for the unit anywhere inside the house. So it was going up in the loft pretty much from day one. I couldn't see anywhere else to put the units. So the main ducts are just running from the unit along the loft floor into a couple of risers. But I did have a couple of branches off to try and minimize the amount of distribution within the house itself. I've also got 1 or 2 ducts on display just because it's a bit of a talking point and it's my job, and but it could easily be sort of boxed into a bulkhead type enclosure if you didn't want to see them. And we do have a couple of bulkheads dotted around very small areas. And we don't have huge floor to ceiling height to play with, 2.34, 2.335 meters. So we weren't going to lower any ceilings. And I didn't really bother looking at the first floor construction to see if I could go through joists and stuff, just because I knew I'd have to change direction in most cases, which would have meant notching quite a few joists, and I wasn't confident with that. So I had a rough idea in my head, but then when it came to it, the MVHR works were expedited anyway because of another delay. I can't remember what it was. There was something they couldn't finish or start, which meant that we could get the MVHR done sooner rather than later. So that was good.
Now, what are some of the challenges of having the MVHR and some of the ducting in the loft? I must admit, I don't see it very often. So how are you dealing with it?
Yeah, I was a bit worried. In fact, generally when I speak to people, I tell them not to put it in the loft, and not a cold loft anyway. So it's fine if you've insulated at rafter level, but if you're trying to hit targets like Enefit, every little heat loss counts, and the amount of ductwork outside of the thermal envelope even insulated, does contribute to the overall efficiency of that MVHR running. So that gets calculated. So essentially, it meant making sure we had insulation around all those ducts that are running in the loft. It did mean I didn't have to insulate necessarily the intake and exhaust. Those were relatively short pieces of ductwork straight out. Having said that, that gable end where it's located has the EWI, so it's not as bad as having a completely cold loft, but still it's quite a blowy place up there, so outside air is blowing around. So essentially, yes, it's a loss of efficiency putting it in that location. So we've tried to minimize that by insulating with 50 mil duct wrap, oil backed wrap.
Do you have to tape that as well and be very conscious of any air and small gaps and things like that?
Correct. Yes, you do. Yeah. And because I went for a sort of rigid metal duct system, that was the approach we took. But you can, with a sort of Lennon box and octopus style distribution, you can often have pre-insulated ducts.
So why did you go for branch?
Mainly because I wanted to avoid plastics and durability, I guess.
Steel, though? Steel, how do you feel about steel?
So it's galvanized steel and recyclable, and I did look into the embodied carbon. A lot of the steel that's used has a high recycled content these days. So, but I also went for durability, and you can always reuse these bits of duct. So that was my go-to.
So this is about £10,000 to get all of this sorted out, and that brings our total to about £63,000 for the retrofit. Now, this one here, I wouldn't necessarily expect it to be next in line, but I suppose you're living in the house. This is what we have to remember. So shading is what we're going to talk about next, which is around
Yeah.
about £5,000. So was this a necessity, or how did shading come into play? And £5,000 really is not that much for shading. You can spend an awful lot on shading.
Yes, I guess you can. Yeah. It was meant to be done in that phase with the external wall insulation. And I always thought, because having lived in the house, we already knew that the southwest facing bedrooms were already a problem. So before even insulating the house, just because that low angle evening sun really gets trapped and the bedrooms overheat. So we knew that that was going to be an issue. Being half French, half Italian, I was used to shutters, visiting family. So it was totally bonkers to me, whenever in a professional setting, I'd suggest shutters and they would be like, oh, shutters. Really? But that's going to add all sorts of costs. And you're like, okay, doesn't matter what else the priorities are. But it literally slashes air conditioning loads, for example, in a commercial building. And it makes it a whole lot more comfortable in domestic settings. So, yeah, why wouldn't you?
It is just such a big win. It's always the question about how you do it, and try not to do the silly thing of making your windows ginormous and then having to have some very complicated solution to do all the shading. So I like also, maybe you could describe these blinds that you have that roll across the upstairs windows.
Yes. In my mind, initially, they were just going to be very simple, sort of outward opening shutters that you pull to and latch and whatever. And then we realized actually our windows are quite large. And because of this sort of simplifying the number of panes business and only having one openable side, so only a third of the whole opening is openable, actually that was never going to work. And also there wasn't enough wall between the windows or to the other side of the window to have that kind of mechanism. I mean, you can have sort of obviously hinged, triple hinged or whatever, so they fold back and everything. But even just reaching to pull it open or pull it shut was tricky. So we quite quickly sort of moved to sliding. But even then, it was quite a challenge finding the right dimensions, the right sliders, and then eventually just, how on earth do we fix this thing, which is solid wood, onto the external wall insulation. Although we did take some preventive measures and put some couple of lintels, just fixed a couple of lintels above and below the windows made of some compact foam composite material that would be less of a thermal bridge than, say, timber.
And how is this all doing with comfort then? Is it working?
Oh, yeah. I mean, to be fair, the big heat wave that we had was before we installed the shutters, and we were faring really well compared to others just by virtue of the wood fibre, which is quite dense, so has thermal mass, and the MVHR, which is giving us bypass fresh air and also cool recovery. So if it was cooler inside than out, we could recover that as well. So we did all right, all things considered, in that heat wave. But there's no denying that when you've got a hot bedroom, it's really difficult to sleep, and it's just miserable. So since we've had the shutters, it's been a lot more comfortable, including in the shoulder seasons where it's not necessarily warm outside, but you do get a lot of sunshine through. And it also means you can shut the shutters, but have the window open if you wanted it. And you still have some kind of privacy or sound barrier and security system. It's, yeah, I don't know why they're not put on every single building, to be fair.
Is there anything else that you would like to shade, or is that you done?
Just that my son complains of the sun waking him up in the summer, even with blackout curtains. He's on the northeast side of the building, so he doesn't necessarily suffer from a very hot bedroom, but kind of has to drape blankets around his bed just to.
Well, interestingly, that's a very similar orientation to what I'm looking at and considering getting some external shading. It's that very 3 o'clock in the morning sunshine.
Yeah,
And in
yeah,
our house, you get 3 or 4 hours of that. You can feel the temperature starting to go up. Definitely,
yeah,
definitely.
yeah, yeah. There's also the ground floor southwest, but we seem to be able to manage that. And also because we've got hedges and trees not so far, that seems to be enough for now anyway. But we could put some kind of awning eventually if it did get too much.
Let's recap where we're up to then. So, round about £69,000. We've just spent £5,000 on those shading devices. And we're moving on to the floor, which is again quite interesting. I don't see this too often in a retrofit, but tell me about what's going on with the floor. You've obviously got to take a floor out, or, all the decisions around the floor.
Oh my gosh, yes, the floor. We deliberately left it till last because I hadn't actually made a decision of what I wanted to do with the floor. My gut was I didn't really want to change the construction type of the house too much because the embodied carbon has already gone into it. It was a suspended timber floor in keeping with the rest of the timber theme that we had. And then you also sort of start thinking about floor finishes. And it seemed to me when I first started out planning this, the two options were either insulate between the joists with a airtight and wind-tight membrane, but you have to keep the ventilation to the joists going, which was quite a big compromise from a thermal point of view. Or you take out the joists and put in a solid floor, which at that time it seemed like the only real option was concrete. But I really didn't fancy concrete for all sorts of reasons, not least embodied carbon and how cold and hard it feels, I guess. So for a long time, we thought we were going down the road of just insulating between the joists, maybe with jute or hemp or wood fibre. One thing you can do is put a layer of insulating material on the ground below that without blocking any vents. And that just sort of raises the ground temperature a little bit. But it seemed like with outside air sort of just flowing through that cavity, it just felt like a bit of a waste in some ways. So that was the plan. And then my husband just saw a tweet from the natural builder talking about earth floors, and I saw some of the images.
It's his speciality, isn't it, Jeffrey?
Yes, yes, Jeffrey. And just looking at the build up. Yeah, so sorry, with the suspended timber floor, we would have just taken the hit on the U value, the resulting U value, and probably would have meant not hitting Enefit in the overall picture. But yes, this earth floor came up. So I did a bit of research, spoke to another retrofit assessor that we know who'd had an earth floor put in with underfloor heating. There was also another option, which would have been hempcrete with the 2 Mauer system. And so the layers are very, very similar to that hempcrete system. So it's recycled foam glass aggregate as the insulating layer, and then compacted soil on top. So yeah, it was very much a hard decision there. But I felt like if it was an earth floor rather than a concrete floor, it wouldn't be so cold and hard. The embodied carbon would be slightly less. And it just felt, yeah, it's just one of those things you just feel like it's the right thing to do.
Do you insulate underneath it?
Yes, that's right. So, but just with this Glaypore or geocell aggregate, which is about 450 mil deep. We had, a very deep void, so we had quite a lot of height to play with. And it's these, I don't know if you, it feels like, the fake fires, the gas fires that have these fake charcoal things. If you've ever lifted one, they're quite lightweight and have a strange texture, but it feels a lot like that. It's inert, it's hydrophobic. So you put down a sort of geotextile membrane, fill up to 450 mil of compacted geocell or Glaypore, and that gives you most of your insulation. And then you've got compacted soil on top. In our case, we used what they call MOT type 1. That got compacted down. So you end up with a very solid base. And then the earth floor, which is clay, lime, sand mixture, and then whatever dust you use to give the pigment. That's only a 20 mil finish in the end. So it's quite a deep build-up. Most of the material cost was in the geocell. And that earth finish is then waxed and oiled, or oiled and waxed, maybe, and then buffed.
It's a lovely finish, talking point, no doubt. Did it go down okay as anticipated? Were there any challenges, and how do you reflect on the money spent, which is around about £30,000 on this, bringing the retrofit price up to nearly 100,000. We're 99,000.
Correct. Yes, that's right. The original estimate was 20 something thousand, but we did suffer a few delays, not least because the amount of recycled foam glass was miscalculated. So once it was compacted down, we had another 150 mil to fill. So that needed to be ordered again and compacted down. So there was a bit of time for that. And then the MOT was very wet and didn't dry out in time for when they were supposed to put the earth floor down. It was also very large stones, which meant they couldn't level it out properly. So they ended up with a sort of fine granite topping. There was a bit of miscommunication about having a cork perimeter or no cork perimeter. So they'd started installing that, and then it got taken out. I insisted on no skirting boards because I just hate them. And we talked about having a pard coat that went, from the wall, the inside wall, right the way down. And that got missed out. So it had to be retrospectively finished off. But in doing so, we had to protect the earth floor, which meant this kind of underlay and then OSB boards on top. So yeah, quite a few delays. We had arranged to go on holiday for most of it, and then we were staying with in-laws and then friends and then more friends.
I did wonder about asking how inconvenient that was.
Yeah, absolutely. But because you can't actually walk on the floor for a few weeks, we basically had to move out of the ground floor. So all the stuff went upstairs and in the garage and got binned or passed on secondhand. The most inconvenient thing was just the fact that the kids were starting school and we still back in. Um, when we went back to the house and moved back in, our neighbors were like, "You do realize your house was humming overnight?" I'm like, "Humming?" Because they had to use these massive fans to dry out the floor. And then I checked my solar PV app, which tells me, all my electricity consumption. And there's this massive peak, this massive consumption of electricity overnight and throughout the day. So yeah, that was a bit unexpected. But it was a learning curve for everyone. You can't really do this kind of thing without expecting a few bumps along the way. And my catharsis is to write about it. So
Well, you've done a very good job, and we'll link up the blog posts with all these things that we've been talking about. I've got one more on my list anyway, which is hot water. And that is around about £7,000, which I believe brings us right up to date now. So around about £106,000. So if you can fill in that one there, and then I think I've got a couple of questions more, and then we can let you go.
oh, brilliant. Yeah, fantastic. Yes, hot water. We've literally just had the hot water installed, the hot water cylinder installed. So the idea was always to get off gas. And until now, we've been eking out this old boiler that kept, every year there was something a little bit more wrong with it. And after the major phase, we'd only taken out two radiators upstairs, which were the southwest facing bedrooms. So actually, we found out we didn't really need the radiators in there much. The boiler was still providing heating and it was a combi, so our hot water instantaneously ish. And after the earth floor, we didn't have any radiators downstairs anymore. And by Christmas, my son's bedroom radiator was failing. It was leaking. So we had to turn that off. So over the winter, last winter, we had one radiator still working and the towel rail off the boiler. We did have to use a few electric heaters around the house and a bit more than I'd anticipated. That's another funny story. I'll come back to that in a minute. So with the hot water cylinder, we have now managed to get rid of our aged boiler. We've got rid of the last remaining radiator and the towel rail. So we have no more wet system installed. We've been told it'll cost about £160 just to get rid of the gas meter. And once that's done, we won't have the standing charges anymore either. So that'll be good. So the hot water cylinder is a Mixergy tank. It's a bit of an intelligent hot water tank. We've also put that in the loft. I always thought it was going to go in the landing cupboard, which was where the boiler was, but it is a bit tight in there. And it means we've recovered a bit of space, actually. So that's gone in the loft, and we're planning to build sort of an insulated cupboard around it. The tank itself has a baffle, so it heats from the top down and it separates the cold from the hot. So you've always got an amount of hot water that it draws off. And not only that, but it uses machine learning and a PV diverter. So any excess solar that we've got generated can just get dumped into the immersion heater and get stored as hot water. So yeah, so I had a schedule set up for a couple of weeks to start with, but now it's just on machine learning and it's just heating as and when we need it. And it's quite impressive actually. It wasn't without its challenges. We were 5 days without hot water because actually the PV diverter initially didn't work, so we needed a new one. So we were on full immersion a lot of the time. We're just trying to find our feet as well, once we did get something up and running.
So, what are you using for heating then?
Electric panel radiators is the plan for the whole house. And at the moment, I've only got a couple installed, very small ones downstairs. We borrowed some portable ones last winter, and there are a couple of reasons why we were cold, even though we'd done all this insulation work. In fact, it was my hot water installer who suggested actually throughout that winter you would have still been drying out the floor, because he sees on new builds anything that has sort of concrete or drying out processes, the heating bill does drop year on year for a good 2 or 3 years because you're still drying out that construction. So that was quite interesting. But also, what I hadn't really realized, and I thought it was down to the fact that I put it in the loft, was that the MVHR was not actually doing full heat recovery for a long time because of a control setting, which I only found out
Oh,
about
what?
in April. I know. I know. So it was on full bypass. It was still giving us a bit of heat recovery somehow. I'm not sure. We were still getting 3 or 4 degrees uplift sometimes. And it was only when the temperature outside dropped to 3 degrees and below that we were getting full heat recovery, presumably because that's the trigger point for the post heater. And so, in order for the post heater to work, you need the full heat recovery to be operational. So, in the middle of winter, we were like, oh, I hope it goes down to below 3 tonight. It was just ridiculous. We were waking up and the downstairs was 13, 14 degrees, and we just weren't expecting it. And so, after numerous emails back and forth, I just read the manual, and it just described this partial bypass setting, which is basically what we should have been on all winter.
Now, all this money that you've spent on your project, firstly, can you anticipate any other significant outgoings, or are we there?
I have one big phase which I'm not looking forward to, which is the airtightness of the ceiling on the upper floor. Because although we've insulated the loft, and that's another reason why our heat losses are still not down to Enofit, we've still got cracks in the plasterboard, and there was a bit of a leak in the condensate from the MVHR. So we've got a hole that's just covered up with a piece of ply now in the bathroom. And I haven't actually got a loft hatch yet. We've just got a couple of pieces of ply and the insulation layer on top, which makes access interesting. So we still have to do that. And the way we're going to do it is taking those plasterboard ceilings down, which is, I'm told, a very messy, messy job. So the carpets upstairs are just horrible, and I want to get rid of them ASAP. But there's no point me doing that until we've done that piece of work. So that is the final
The last
stage.
piece. Well done. How do you feel about the money you've spent? So we're at the moment on this figure of about £106,000, maybe in relation to the house. How do you feel about it? Is it something that will encourage other people to go down this route?
100,000 was what I was expecting roughly
Good.
for a deep retrofit. The only reason I was expecting that was through discussions with Carbon Co-op and People Powered Retrofit when we were discussing what that level of retrofit entails. And they were saying, you're not going to do it for 50, 70 grand. You need to spend in excess of 100,000. And although it does sound like a lot of money, the house itself has probably increased in value, not necessarily through the retrofit itself, just because of market forces where it is. And that's totally outside our control. But the retrofit will hopefully now, when you see energy price increases, it will start to have an effect on market price of the house. Not that it's anything that interests me. This is the house that we're hoping to live in for quite a long time.
Yeah, I don't think you'd do this to just sell your house, really, would you?
No. Quite a lot of yourself gets poured into it as well. So the idea that someone might raise it to the ground would be it's
Now,
kind of heartbreaking.
How do you want to close up then today? What's your final thought, or have you got some learnings?
There's a lot of talk about heat pumps and whether you should do any fabric first based on the fact that you could swap your boiler out for a heat pump and kind of be net zero ready, or whatever the catchphrase might be. And I design heat pump systems. I love heat pumps. I think they're an incredible technology. But just reducing it to that sort of, it's either this or that option, means you're missing out on a whole lot of the nuance around your own home and how you operate it and how you feel in it. You might be able to get the numbers to stack up, although that really does depend on your house and how you use it and what you're swapping from. But the really important part of this retrofit, apart from the carbon emissions, is the health aspect, the comfort aspect, the general quality of life that we have because of the fabric improvements that we've done. And some of the things like, surface temperatures being even across the board. You wouldn't even know that was an issue in your house necessarily. You just wouldn't feel comfortable a lot of the time. You'd just always be cold, and there'd be some kind of draft and you wouldn't know where it's coming from. The idea that you have moisture and condensation, and actually the compound benefits. So MVHR, I think, it's just really comfortable. It's quiet. You get filtered fresh air constantly, but it also means that if you're an allergy sufferer, you're not getting the pollutants from outside or the pollen, but also those issues of drying your clothes inside, they disappear because you're always drawing the moisture out of the house without having to heat that evaporated moisture. And you don't get the condensation that you would if you were to, put wet clothes on radiators and that kind of thing. So you end up not using the tumble dryer has been in the garage since phase 1. I think I used it maybe twice after the EWI went on, just through habit. But it's also now been buried, and I don't miss it at all. So that's another energy cost that's disappeared that doesn't necessarily get into the calculations. Just small nuanced things like that together make it all really worthwhile to do the deep fabric retrofit.
Yeah, you're talking our language here. Florence, thank you so much.
You're very welcome. It's been a pleasure.
Head online to take a look at the show notes that accompany this session. houseplanninghelp.com/370, where we've got the summary for you so you can go through that once again with links within it that will take you across to the more in-depth blog articles that Florence has written. If you've got a comment or you'd like to ask a question, we always say you can do this within the show notes. Just head down to the bottom or on social media. We'll provide links in the show notes. And then, of course, a link to Humblebee so you can go across to Florence's website, houseplanninghelp.com/370. My call to action is to check out the Hub, and this is the membership community that I run alongside House Planning Help. The idea being to help you further, more assistance, but one of the major challenges that you have is that building a new home or retrofitting an existing property is it's huge. It's a huge project that will take you probably years, even if things go really well. And that's hard to understand what lies ahead of you when you're at the beginning. So I want to intercept you at the beginning, help you with that learning curve, lay out the steps, and give you some examples as well. For example, in the hub, we've got our in-depth video case studies that you can take yourself through, and we're always focusing on decision making, so you can check out the different stages of the project, what decisions are being made. We've got other things in the hub as well. We've got courses that do a similar thing, try to focus on a particular topic and take you through. You can chat with me in office hour or one of our experts. We've got Ask the Expert. We've got our live training session with guest experts that come in. So we try to just make it a really good experience. And one thing I haven't mentioned is networking with like-minded builders, self-builders or retrofitters as they go through as well, all at different stages. It's a lovely feeling in the community. Come and find out more. houseplanninghelp.com/join. Next time, Chris Brookman from Back to Earth is my guest, and we're going to be focusing on wood fibre insulation. It tends to be a very popular one. A lot of people like wood fibre insulation, so we'll find out how you use it the right way, where it lends itself to, all of that next time. Thank you so much for listening. The House Planning Help podcast is produced by Regen Media, content that matters.